Hello there. This is Ms. Nakayama, and today's lesson is 9.3 confidence intervals. Now, before we can actually build those confidence intervals and talk about them, I need you to know what a margin of error is. So the best way I think is to show you an example. A study was commissioned to find the mean weight of the residents in a certain town. The study found a confidence interval for the mean weight to be between 193 pounds and 201 pounds. What is the margin of error on the survey? Do not write plus or minus on the margin of error. So if you think about it, you have an interval, okay? And that interval goes between 193 and 201. So we are trying to figure out what the margin of error is in that interval, so we need to know how far it is from the mean, or this middle point. So that's the midpoint, so we're going to take 193 plus 201, divide by 2, and we're going to get 197. So this point in the middle is 197. Your margin of error is the amount that you deviate from that mean. So either direction, that's why he's saying plus or minus. Don't worry about the plus or minus. Just tell us how far away is it from the mean. So clearly you just subtract 201 and 197, or 197 and 193, and you will find that the margin of error is 4. Okay, now that one was pretty straight up. Sometimes they give you one like this. A survey was given to a random sample of 1,100 residents of a town to determine whether they support a new plan to raise taxes in order to increase education spending. Of those surveys, 242 respondents said they were in favor of the plan. At the 95% confidence level, what is the margin of error for this survey expressed as a proportion to the nearest thousand? So that's a key word in this problem here, proportion. Because that means we're going to use a margin of error for proportions. And it looks like this. You will need to know this, so you should write it down every time you do it. Okay, the 2 is coming from the fact we are at very simple basic statistics, not AP statistics. So this 2 is coming from the fact that a 95% confidence level is 2 standard deviations away from the mean. Now, the rest of this little p with a symbol on top of it is read p hat. So it's p hat times 1 minus p hat. So you could kind of think of that as success and failure. And n is our sample size. So in this particular problem, our sample, of course, is 1,100. So that's our n. And we've got to figure out what p hat is. Well, if I'm trying to figure out they tell us that 242 respondents said they were in favor of the plan. So we're going to go figure out p hat by taking those 242 and putting it over the total of 1,100 residents. So our p hat amount is 0.22. So I didn't write this down, but I hope y'all know that means that 1 minus p hat that I'm going to put in my formula is going to be equal to 1 minus 0.22, which is 0.78. Okay, so my margin of error using this formula right here is going to be, I'm going to plug in 2 times p hat, which is 0.22, and 1 minus p hat is 0.78, and my sample size is 1,100. So my margin of error in this case for a 95% confidence level would be 0.025. Now, if you wanted the interval, then you would take this. Well, we'll get to it. I don't need to go there. Let's keep going. Okay? So, example 3. A survey was given to a random sample of 1,950 residents of a town to determine whether they support a new plan to raise taxes in order to increase education spending. Of those surveyed, 741 respondents said they were in favor of the plan. Determine a 95% confidence interval. So this one is different. This one right here asked for the margin of error, so I stopped. This one is asking us for the confidence interval. So you really got to pay attention, again, for the proportion of the people who favor the tax plan. So we're going to be using that same formula that we had before to find our margin of error, and that was 2 times the square root of p hat times 1 minus p hat over n. So to determine my p hat, remember my sample N is 1,950 residents, and I have that 741 responded they were in favor of the plan. So my p hat is going to be 741 over 1,950, and that gives us a value of 0.38. So I hope y'all can figure out. So when I plug these in, p hat is 0.38. 1 minus 0.38 is going to be 0.62. And my N is 1950. So when I plug that in, that's going to give me a value of 0.02198. Remember that if he says rounding the values, that means my answer is to the nearest thousandth. So 1, 2, 3, you need to make sure you go further than that. If I had gone just one place further, that would be a 2, and then it would be thousandths. So it's really safer. Actually, I only used 2, 1. That's not good. Anyway, so pause 1 second. So I realized that I rounded and I shouldn't have, but we're going to keep on going. So I have my margin of error. So remember, you think about your interval, okay? And my median point is 0.38. So I'm going to add and subtract my margin of error. So when I take 0.38 and subtract 0.02198, I'm going to get a number, and I'm going to do 0.38 plus that. So when I did that, I rounded, which means those aren't the correct numbers, and this really should be 358. Okay, and this would be 0.402. So keep that in mind. If you miss it, y'all, it's probably because you rounded to that nearest thousandth before you should have. All right, so keep that in mind. Example 4. A study of a local high school tried to determine the mean amount of money that each student had saved. The study surveyed a random sample of 99 students in the high school and found a mean savings of $2,900 with a standard deviation of $1,400. At the 95% confidence level, find the margin of error. So we're not looking for the interval, just the margin of error for the mean. Okay, but that's kind of a key word in this problem here is now it didn't say proportion, y'all. It said mean. So we have a different formula, and that formula looks like this, a little simpler, okay? Again, 2 is relating to the 95% confidence interval, and I say that because in Delta Math, it explains more for you. S is our standard deviation, and the square root of n is our sample size. So we know that if we're going to go find that margin of error, my standard deviation is over here, is at 1,400, so that's going to go up top here. And my n is my sample size, and that, of course, is 99. So my margin of error in this case is 281.41. They want us to round to the nearest whole number, so that would be 281. If they ask me for the interval, okay, then I would take my 2,900 because that's my mean right up here, and then I would add 281 and subtract 281, which is what we're going to do on the next one. So you just got to pay attention to what it's asking, okay? Example 5, a study was commissioned to find the mean weight of the residents in a certain town. The study examined a random sample of 72 residents and found the mean weight to be 150 pounds with a standard deviation of 30 pounds. This time we actually have to find the interval. So I found the interval last time. We didn't have to. We just got to stop at finding the margin of error. But just remember, the margin of error is how far you're going from the mean. So determine the 95% confidence interval for the mean, rounding all values to the nearest tenth. So my margin of error is 2 times the standard deviation. Where's my standard deviation? That's right up here. So 2 times 30 over the square root of my sample size, which is 72. So when we multiply that out, we get 7.071. Okay, and remember that my interval, this time they're asking us for the interval. So I start with my mean, okay, which is 150, and I'm going to add and subtract the margin of error. So and they say round to the nearest tenth. So hopefully I did add and subtract 7.1, 150 plus 7.1, 150 minus 7.1. And so our interval My 95% confidence interval is going to be 142.9 to 157.1. So the last thing, I didn't want to make this too long, y'all, but the last two types of problems you have are simulations in Delta Math, and you have to just follow the directions, and you're actually picking the numbers out to sample. And in the first one you will actually go find the mean because you copy and paste the values into a stat calculator. And then you use it, and you will use this formula because it's the way it's set up. It will tell you that you're finding it from the mean. And then on the second type, you're not given a mean, so you're going to find your p-hat. I left my hats off of that right there. Okay, but either way, you have the mean, and remember that when you find the p-hat, again, left my hat off of these. Not good. When you find that p-hat number, that's what comes down here. Over in this problem, you actually know what the mean is when you're doing it, putting it in Delta Math. So, hope that wasn't too bad. And please don't hesitate to come see me or email me if you have any questions. Come see me the next morning also. Thank you so much for watching, and y'all have a great day.